Good day, everyone. Welcome to another video learning with Bahagharing Lexi. And today, what we are going to discuss is all about domain and range of an inverse functions. And with this presentation, we are going to determine the domain and the range of an inverse function. Now, in our previous discussion, we discussed that two functions, f of x and g of x, are inverse functions if and only if, for each x in the domain of our g, g of x is in the domain of f, wherein f, composite of g, is equal to x. And for each x in the domain of f of x is in the domain of g. That is, g, composite of f, is equal to x. And also, we discussed that we do have three-step rule in finding the inverse of a one-to-one function. And what are those steps? Number one, you have to change f of x to y if the given function is stated or expressed as f of x. Then you have to solve the equation for x in terms of y. And then after that, interchange x and y, and the resulting equation is now the inverse of the given function. Okay, let's have our illustrative example in finding the inverse of a one-to-one function. Now, this is a quadratic function, and we know that this quadratic function is a many-to-one correspondence. Therefore, we are going to have restriction for this quadratic function to make the given function a one-to-one function. We are just going to utilize x is greater than or equal to 0 so that we are going to come up with the inverse of the given function. Now, in this case, what will be our procedures? We have the first one, change f of x to y. Thus, we do have y is equal to x squared minus 4. Then, solve now the equation for x in terms of y. That is, y plus 4 is equal to x squared. That we transpose negative 4 on the left side of our equation. And then y plus 4 is equal to x squared will be multiplied by the inverse of the exponent 2. That is raised to 1/2. And then applying the concept of the power law, we are going to have the quantity y plus 4 raised to 1/2 is equal to 2 times 1/2, and that will become 2 over 2. Now, 2 divided by 2 is equal to 1. Therefore, our exponent for the variable x will become 1. And on the other hand, our exponent is a fraction for the quantity y plus 4. And this indicates that the given 1/2 will be expressed as a radical symbol. And knowing that our index is 2, therefore our root will be 2. Thus, this will become square root. Therefore, this is square root of y plus 4 is equal to x. And then after we able to find the value of x, then we have to interchange now x and y. But remember, the resulting equation is now the inverse of the given function. That is, the square root of x plus 4 is equal to y is now expressed as the inverse of the given function is equal to the square root of x plus 4. Wherein x now is greater than or equal to -4 so that we are not going to come up with an imaginary solution. Okay, after we're able to find the inverse of the given function, what if we are asked to find for the domain and the range of an inverse functions? Now, going back with our definition about domain and range, let us recall what is domain, or what is domain? Domain is the set of all values of x, which is the input of the given function in the given function. That is the set of all values of x in the given function. Now, looking back with our table here, the values that we assigned for the variable x are what we call the domain. Same with the second table of values, we do have 3, 6, 9, 12, 15 are what we call the domain of the given functions. On the other hand, when we talk about range, this is now the set of all values of y, which is the outcome or the output. Now, in the given function, okay? Therefore, going back with or looking with our table here, the values that we attained or the values that occurred when we replaced x by -2, -1, 0, 1, and 2 for the first set of table of values for the given f of x, we have 3, 6, 9, 12, and 15. These are what we call the range of the given function. Same with, we do have -2, -1, 0, 1, and 2. These are what we call the range of the given function g of x. Now, what about if we are going to get the domain and range of the given inverse functions? Okay, what if we are asked to find for the domain and range of an inverse function? For example, find the domain and range of the given function and its inverse. Now, I will be using the previous examples on the last video discussion that I uploaded. Now here, I do have here f of x is equal to 3x plus 9. The second function is f of x is equal to x cubed plus 5. The third one is f of x is equal to the square root of x minus 1. And then the fourth one will be f of x is equal to x squared minus 4. And the last one is f of x is equal to 2x plus 1 all over x minus 3. Now, observing the given different functions, okay, what will be the domain and range of the given 5 functions and its corresponding inverses, okay? Now, we have to identify first what type of function are we dealing with, because we do have classifications of functions according to degree. Now, for the first, we have f of x is equal to 3x plus 9. This is a linear function. For the second one, this is a cubic function. For the third one, we do have the radical function. For the fourth one, we do have quadratic function. And for the fifth one, which is the last one, we do have the rational function. Now, each functions have its own properties. Therefore, from the concept that we learned from our junior high school mathematics, we are going to use that concept in determining the domain and range of the given functions and its corresponding inverses. Okay, let's start with number 1. Now, last time, we able to deal with the inverse of 3x plus 9 is equal to f of x. And our answer here is the inverse of the given function is equal to 1/3 x minus 3. Okay, now remember class that f of x is equal to 3x plus 9 is a linear function. And as linear function tell us, any real number can be replaced or can be substituted to our variable x. Therefore, our domain for the given f of x is equal to 3x plus 9 will be set of any real number for x, or x is any element of a real number, or we can use using the notation, we do have negative infinity to positive infinity. Now, if our domain or if the value of x is any real number, therefore the outcome will also be any real number. Therefore, the range will be y is any element of a real number, or y is any real number, or we can express that one into a notation that is negative infinity to positive infinity. Now, this is the domain and the range of the given function. What about its inverse? Okay, we do have the inverse of the given function is equal to 1/3 x minus 3. Now, since the given inverse is also a linear function, therefore, the value that we can assign to x will be any real number. Therefore, our domain will be x is any real number, or we can write that one in notation form. We have negative infinity to positive infinity. And since we can use any number for our x, therefore the outcome or the output rather will be the range, which is y is any real number, or negative infinity to positive infinity. This is for linear function. Another example that we have is f of x is equal to x cubed minus 5. And the given function is a cubic function for the reason that our degree or the variable's exponent is equal to 3. And if we are going to get the inverse of the given function, therefore following the three-step rule, thus the inverse of the given function will be the cube root of x plus 5. Now, the question will be, what is now the domain and the range of the given function and its corresponding inverse? Now, going back with our function, which is x cubed minus 5 is equal to f of x. Now, any number can be replaced for the variable x. And since this is a one-to-one correspondence, therefore, the domain will be x is any element of a real number, or we can have our notation negative infinity to positive infinity. Now, on the other hand, for the range, since we can assign any real numbers for x, therefore the outcome or the output will be y is any real number, or y is any element of a real number, or by notation, we can also use the negative infinity to positive infinity. On the other hand, the inverse of the given function, which is the cube root of x plus 5, we can assign any real number for x, because we are not going to come up with an imaginary solution, imaginary number. Therefore, our domain here will be x is any real number, or x is any element of a real number, or we can have the notation set negative infinity to positive infinity. Same thing for the range, we do have y is an element of a real number, or using notation, we do have negative infinity to positive infinity. Okay. Now, another example that we have is the radical function, which is f of x is equal to the square root of x minus 1. Now, in this case, since this is a square root, okay, square root of x minus 1, wherein our index or our root is an even number. Therefore, we are going to have restriction. Why we have to provide a restriction? Because if our x will be 0, for example, then our radicand will be negative 1. Therefore, the square root of a negative 1 is equal to the square root of negative 1, which is an imaginary number. And in this case, we are going to limit that it will occur an imaginary solution. Thus, we are going to equate our radicand by x minus 1 is greater than or equal to 0. That's why we do have here x is greater than or equal to 1 so that we are not going to have an imaginary solution. Okay. Therefore, using the three-step rule, the inverse will be x squared plus 1. X squared plus 1. And since our inverse is a quadratic function and the graph is a parabola, therefore, we are going to limit or make restriction for the values of x. Okay, because parabola is a many-to-one correspondence, or a quadratic function rather is a many-to-one correspondence because it touches at most 2 points using the horizontal line test. Therefore, our x will be greater than or equal to 0 as our restriction. Okay, now what will be our domain and range for the given function and its corresponding inverse? Okay, since we do have restriction for our x, which is x is greater than or equal to 1, for the given function f of x is equal to the square root of x minus 1, therefore our domain will be x is an element of a real number such that x is greater than or equal to 1. Or we can use notation symbol that is bracket 1 up to the positive infinity. We are going to use the bracket because 1 is included in our value for x. Okay. Now, if our x is 1, because 1 is the minimum value for x. And if we are going to replace x is equal to 1 in our square root of x minus 1, therefore 1 minus 1 will be equal to 0. And if you are going to get the square root of 0, the answer will be 0. Meaning to say, the least possible outcome for the y will be equal to 0. Thus, the range will be equal to y is any element of a real number such that y is greater than or equal to 0. Or by notation, we can use bracket 0 up to the positive infinity. On the other hand, for the inverse of the given function, f of x is equal to the square root of x minus 1, wherein the inverse here is x squared plus 1, which is a quadratic function. We also have restriction, which is x is greater than or equal to 0. Therefore, our domain will be x is any real number such that x is greater than or equal to 0. Or by notation, we do have bracket 0 to positive infinity. And if we are going to replace or substitute x by 0, therefore 0 squared is equal to 0 plus 1, the answer will be 1. Therefore, the minimum outcome or output for y will be positive 1. Thus, the range will be y is any real number such that y is greater than or equal to positive 1. Or by notation, we do have 1 open bracket to positive infinity close parenthesis. Okay, another example that we have is f of x is equal to x squared minus 4. Now, this is a quadratic function. And this is a many-to-one correspondence. Therefore, we are going to provide restriction, and our restriction will be x is greater than or equal to 0. And what will be the inverse? The inverse will be square root of x plus 4. And same thing, we are going to have restriction, and our x will be greater than or equal to negative 4 so that we are not going to have an imaginary solution. Now, the question here is, what will be our domain and range? Okay. Now, the domain and range for the given function, f of x is equal to x squared minus 4, since we do have restriction for x, which is greater than or equal to 0. Therefore, our domain will be x is any real number. Okay, or x is an element of a real number such that x is greater than or equal to 0. By notation, we do have bracket 0 to positive infinity. On the other hand, if we are going to replace x is equal to 0 to our x squared minus 4, the result will be negative 4. Okay, that is 0 squared is equal to 0. Minus 4, the answer is negative 4. Therefore, the range will be y is an element of a real number such that y is greater than or equal to negative 4. Or by notation, we do have the bracket negative 4 up to the positive infinity. Okay, now what about for the inverse? We do have square root of x plus 4. And our restriction will be x is greater than or equal to negative 4. Therefore, our domain will be x is an element of a real number such that x is greater than or equal to negative 4. Or by notation, we do have negative 4, open bracket, up to the positive infinity, close parenthesis. And by substitution, if our x is negative 4, negative 4 plus 4 will become 0. Square root of 0 is equal to 0. Therefore, the range will be y is any element of a real number such that y is greater than or equal to 0. Or by symbol, bracket 0 up to the positive infinity, close parenthesis. Okay, another example that we have is a rational function. Okay, and when we talk about rational function, in our previous discussion that we had, we do have restriction for our denominator so that we are not going to come up with a undefined solution. Therefore, in this case, we are going to have restriction for our x. Therefore, x should not be equal to positive 3 so that we are not going to have an undefined solution. And what will be the inverse of the given f of x is equal to 2x plus 1 all over x minus 3. Now, using the three-step rule, okay, therefore, our inverse will be 3x plus 1 all over x minus 2, wherein we also have restriction for our x, and that is not equivalent to positive 2. Okay, now in this case, after knowing the inverse of the given function, now what will be our domain and range? Okay. Okay, now since for the given function 2x plus 1 all over x minus 3, we do have restriction for our x, which is not equal to positive 3. Therefore, our domain will be x is any real number as long as x is not equal to 3. Thus, any number can be utilized. That is 3 to negative infinity or negative infinity to positive 3, but 3 is excluded. That's why we are going to use close parenthesis. Union of 3 to positive infinity. Okay? Meaning to say any number, as long as that is a real number, can be utilized for x. But you are not going to use x is equal to positive 3. You are not going to use. That's why 3 here is excluded in our value for the domain. On the other hand, okay, and for the range, our range will be y is any real number, or y is an element of a real number such that y is not equal to 2. Meaning to say, we are not going to have a value equivalent to 2. And how did we able to find that one? Applying the concept of what we learned about the horizontal asymptote. Therefore, since our degree for the numerator and denominator is the same, therefore get the quotient, and that is 2 divided by 1 using the leading term of our numerator and denominator. Therefore, the answer will be 2. Therefore, 2 will be excluded as an outcome or output for y. Or we can use notation symbol. We do have negative infinity to positive 2, open and close parentheses, meaning to say 2 is not included. The union of 2 to the positive infinity. Okay? 2 is not also included. Therefore, it is an open parenthesis. On the other hand, for the inverse, if x is not equal to positive 2, therefore our domain will be x is any element of a real number, or x is a element of a real number such that x is not equal to positive 2. Okay? And then in this case, we do have the notation symbol, negative infinity to positive 2, union of 2 to the positive infinity, open and close parentheses. And applying the concept of what we learned from horizontal asymptote concept, therefore our quotient here will be positive 3. Therefore, the range will be y is an element of a real number such that y is not equal to positive 3. Or by notation, negative infinity to positive 3, open and close parentheses, union 3 to positive infinity, open and close parentheses. Now, from that concept, we're able to find the domain and the range of the given function and its corresponding inverse. Okay, now let's go with what is the relationship between the domain and the range of the given function and its inverse. Using the last example, this one. Now, the domain of the given, the domain which is the domain of our inverse, now highlighted with the color green, is the range of the given function. I repeat, the domain of the inverse function of the given function is the range of the original function. I repeat, the domain of the inverse function is the range of the original function. Okay. While the range highlighted by the color red of the inverse is the domain of the original function. Okay, and that's the relationship that we have when we talk about the domain and range of the given function and its corresponding inverse. And with that concept, now, I hope you're able to learn about the relationship and finding the domain and the range of the given function and its corresponding inverse. Okay? Now, this will be your performance task. We do have number 1 to number 5. And remember, And remember, the domain of the inverse function is the range of the original function, and the range of the inverse function is the domain of the original function. With that, I hope you're able to learn from the concept that I discussed. Happy to serve and hope to see you in my next video learning with Bahagharing Lexi. God bless all.